How's it go, Tos? We're going on to question 2 from the Trinity House 2019 prelim paper. Okay, so question A is saying the following geometric sequence is given. So they've given us this. And it goes on and on and on. Determine T12. Okay, because this is a geometric and we have to find a particular term, we're going to be using this formula here. Okay, so the first things first, I need to find out what R is equal to. Remember, R is equal to T2 divided by T1, and we get here minus 4 divided by 2, T2 divided by T1, and we get R is equal to minus 2. We also need our A, so A is equal to 2, the first term. So now we can do this. So T12 is equal to 2 times minus 2 to the power of 12 minus 1. You can just do that on the calculator. And we get T12 is equal to minus 4,096. Okay. Question B is saying the first 3 terms of an arithmetic sequence are, and we've got 10 minus x, 2x plus 3, 4x plus 1. Okay, calculate the value of x. Now, because we know that it's an arithmetic sequence, all right, and if I just make something up here on the side, and then you can see what's happening. Let's say that we've got like 2, 5, 8, and it goes on and on and on. Okay, I know that the common difference would be equal to T2 minus T1. All right, in this case, it would be equal to 5 minus 2, and we get 3. But I also know that the common difference would be equal to T3 minus T2, and we get 8 minus 5, which is equal to 3. Okay, and what I'm going to do is I'm going to use that fact that this T2 minus T1 is exactly the same as T3 minus T2. It'll give us the same answer. So over here, I can say that T2 minus T1 must be equal to T3 minus T2 because they're both equal to the common difference, as you can see from this example over here. So that's all I'm going to do is I'm just going to substitute these values or these terms into here, and then I'll get an equation in terms of x, and then we can solve. So T2 is 2x plus 3 minus T1 is 10 minus x equals T3 is 4x plus 1 minus T2 is 2x plus 3. You can get rid of the brackets, and we get 2x plus 3 minus 10x plus x equals 4x plus 1 minus 2x minus 3. All right, so now we've got a nice linear equation where I can take x's to the one side, numbers to the other side. So here we get 2x plus x is 3x, minus 4x is minus x, plus x is just x, equals. Then on this side here, we've got 1 minus 3, minus 3, plus 10. And we get 5. So that was the first part of the question, is calculate the value of x. All right, so this was question 1b. Question 2b is asking us to find the sum of 23 terms. Okay. And I'm going to try and squeeze it in here. So they're asking us for the sum of 23. Now, the formula that we're going to be using, and this is on your formula sheet, is Sn is equal to n over 2, 2a plus n minus 1 times d. Okay. So I'm just going to substitute everything in here. But before I do that, I actually have to find out what is our actual sequence here. And in order to find that, I just substitute my x in here. So our first term would be 5. Our second term would be 2 times 5 plus 3, which is 13. And then our third term, put the 5 in there, we get 4 times 5, 20 plus 1 is 21. Okay, so that is our sequence that we're dealing with. Now we can find our common difference. So T2 minus T1, and we get 8. Okay, and you can see if you add 8 onto here, you will get 21. So we know that our first term is equal to 5. We know that the common difference is equal to 8, and we know that n is equal to 23. I have everything that I need in order to use this formula. So S23 will be equal to n over 2, so it's 23 over 2. 2 times a, which is 5, plus 23 minus 1 times d, which is 8. And then you can just plug that on the calculator and get an answer. So I'm just going to do that quickly. And we get an answer of 2,139. Okay. Sorry, I just need to scroll up here. Right, question C. Okay, question C is saying the sum of n terms is given by this formula here. Sn is equal to n over 2, 4 plus n. Okay. Determine the value of T5. So T5 is equal to something. So they have given us a sum formula, and they've said for the sequence, it can be modeled with this over here. Okay. Now, before I go into this question, I want to do a side example. So, for example, if we have, let's say we've got a series like this. 2 plus 5 plus 8 plus 11 plus, and it goes on. Okay. Now, if I take the sum of 4 terms, okay, so I'm going to take 1, 2, 3, 4. Add those 4 terms. So we've got 2 plus 5 plus 8 plus 11. And we get a sum of 26. Now, if I take the sum of 3 terms, let's see what that gives us. So we've got 2 plus 5 plus 8, and we get 15. So what I've done here is I've taken the sum of those ones, of these ones here, all 4, and then the sum of just those 3. Now, if I wanted to work out, say, the 4th term, now we can see that the 4th term here is 11. But if I'm only given the sums, how can I work out that 4th term? Well, if I take the sum of 4 terms, subtract the sum of 3 terms, what am I going to be left with? Just that. So let's test it out. So T4 equals the sum of 4 minus the sum of 3. So we got 26 minus 15, and 26 minus 15 gives us 11, and that's our 4th term. And that is the principle that I'm going to use here. So we want to find T5. So we know that T5 will be equal to the sum of 5 terms minus the sum of 4 terms. Okay, and we have an expression or a formula to work out the sum of 5 terms and for 4 for this sequence or this series. So I'm just going to plug in 5 in here, and we get 5 over 2, 4 plus 5. So that is the sum of 5 minus the sum of 4 would be 4 over 2, 4 plus 4. Okay, you can just slap this whole thing in the calculator, and we get 5 over 2 times 9 minus 2 times 8. And we get 13 over 2 is the 5th term. Okay. And that is that for this one. All right, thanks, grade 12s.